almost long. This is FRQ 5 part 8. We are asked to find the angle. Okay, if the angle required to hit the target is known, what distance of the board, measuring distance from the bottom edge of the board, does the ball go before sliding back down? So let me draw the board real quickly, as it will come useful later. Something like this, right? Launch right here, right there. This is phi, and this is theta. This is d, and we'll just denote this as h. So there's a velocity initial. So to find h, because that's the maximum height, to find h, we will need to find, we will use a formula vi squared, or v0 squared, v initial squared, times sine squared theta over 2a. Here we don't use g. A is not equal to g, because this is not a free fall system. It is bounded by a slope downwards, right? So to find the acceleration as it goes downwards, we must find the, if we take this as the acceleration, we have to find the FGX. Or, you know what, doesn't matter. We have to find the acceleration as it goes downwards, right? And what we know about that is that on a slope, the acceleration downwards is given by FG, is given by the gravity times sine theta, right? Acceleration is given by g sine theta. But theta in here it's not theta, it's phi. So we just replace that with phi, and we have found our acceleration that we needed to plug into this formula. So we're just gonna do that real quickly, and so we get the formula h, or the maximum vertical distance, is given by v initial squared sine squared theta over 2 times g sine phi. That's the formula we get for part A. And for part B, we are asked to find, to suppose the angle theta to reach the target were known. Considering the horizontal motion, how long would it take to reach the target? So we are asked to find the time it requires to go through this entire motion. And since we are asked to use d, we will use a formula. D, which is the x-axis, horizontal axis, is given by vix, or we'll put v initial 0x, t times t plus 1/2 ax t squared. And what we know about the acceleration in the x-axis is that there is none, so we'll just get rid of that. So, or the horizontal, there's no force in the horizontal direction, so we can just get rid of that. So we just have this the d is equal to v initial x times t. And what we know about v initial x is that it is equal to v initial cosine theta times t. So we just have to rewrite this function to get t is equal to d over v initial cosine theta. And that's the answer, right? So for part C, gosh darn it. For C, we are asked to, given data, how long time does this reach the maximum height? So we're trying to find the maximum height using v. Okay, so to find maximum height, or the time to get to the maximum height, we can use a formula. T is equal to t, and we'll denote this t equals max height. I should denote this differently. So this is t for total distance. So we just put t total, because we'll use that later on. So t max, so maximum height, is given by vi sine theta over a. And here we know that a is equal to g sine phi. Right? And wait, this should be v0, because they want us to use that instead of vi. So v initial sine theta over g sine phi is a formula to find t max. Yeah, that's it. Alright, for part D, we're asked to find, if the answer to part C is So this is equal to delta Tm. What's the time necessary to hit the target? So in terms of delta Tm, what is the time needed for the ball to go from here to here? So what we know about the relationship between the time for it to go from T0 to T peak, from T peak to T total, is that if this is just this is delta Tm1 Tm, then this is also delta Tm. And mathematically, to prove this, we can just look at it like this. H, so for it to go up and down, or we can just use a more general delta T, delta Y, is given by VI YT plus 1/2 AYT squared. And what we know about VI, A, and okay, so everything here, they're the same, right? So this doesn't change. And since the Y, delta Y, also doesn't change, the only thing, the T value will both be the same. So since the T value from here to here will be the same, and from here to here it will be the same, it just be twice, 2 times the T from the initial to T to the peak. So the answer will be just delta Tm times 2. And that's the answer. Alright, so for part E, we're asked to prove that the angle theta at which the ball, so we're trying to prove that, for E, we're trying to prove that theta is equal to 1/2 sine inverse GD sine phi over V initial squared, right? We're just trying to improve this. So what we first realize is that these make up sine 2 theta. And the only formula that comes up to mind when we are seeing that formula is the horizontal displacement, right? When we're trying to find this. And the D is given by V initial squared sine 2 theta over A, where A is just G sine phi, right? So all we have to do is multiply this to the top. So I'll just do, so we multiply both sides by G sine phi and divide both sides by V, V initial squared. Both sides, G sine phi, V initial squared. And we're left with G dG sine phi over V initial squared is equal to sine 2 theta. And now we can just inverse sine both sides. Yeah, and we can just inverse sine both sides, and then that'll give us sine inverse. We'll just rewrite this GD sine phi over V initial squared is equal to sine 2 theta. And all we have to do is divide both sides by 2, and we're left with 1/2 sine inverse GD sine phi over V initial squared is equal to theta, and we have just proven it. Alright, so the last one, part F, we are asked if only the angle phi of the flatboard is increased, how would the answer of part A change? So we're asked if this increases, well, how would it change the H max, right? Or yeah, H. So I'll bring this equation really quickly. So this equation, what we see here is that phi is on the denominator, right? So if phi was to increase, it affects sine. And what we know about sine is that up till from 0 to 90 degrees, sine will always increase, right? Sine goes from 0 to 1, right? So as phi increases, sine phi increases. So I'll just say, if the angle phi were to increase, the H max. And okay, so I'll explain it one more time. I'll finish my thought. Since sine phi increases, and since this is a fraction, what we know about fraction is that if the denominator increases, the entire fraction, the magnitude of the entire fraction decreases. So h will decrease. So if the angle phi were to increase, the h max would, or the h would decrease because phi increasing would cause sine phi to increase, and since sine phi will cause the magnitude of sine phi to increase, and since sine phi is on the denominator of the formula to find h max, the magnitude of h max would decrease as the fraction, the formula would decrease. I think I can just end it off there. Alright, and that's it. Thank you for watching the video. Goodbye.